Okay, so we are doing a binary divider today, as we have already done this division of 135 by 13. You can see that when we divide, we generally take quotient, compare it with the first bits of the dividend, and then we multiply it with the respective uh, number, and we subtract it, bring the next bit down. Again, we multiply with the quotient, the divisor, get it, and finally we get the remainder. Same thing is done in the binary division. So what all operation is required is, we require a subtractor operation, we also require a comparison operation, and because in binary division it will be either 1 or 0 in the quotient, we have to see that whenever we compare and we get a smaller number as the result of subtraction, or we can say in other word, whenever we compare and quotient divisor becomes big, we only shift the dividend, and it is as good as multiplying it with 0, subtracting, and this one. So what you can see here is, when your dividend bits were higher than the divisor, you were subtracting the divisor from the dividend. Whenever the divisor was higher than the subtraction result, you were not doing anything, you were simply shifting the operation. Means you can see this triple one here and then this one, so we are simply shifting. So when you saw multiplier, you saw that there were two types of possibility. One was add and shift, other one was only shift. So in division operation, what you can see, if your divisor is big, then you subtract the divisor from the dividend and then shift. And if your divisor is smaller than this, you shift only, you do not subtract. The same thing is seen in this. So what you saw, that we tried to divide 135 by 13 and we got the quotient as 10 and remainder as 5. Now the same thing you should understand here. Here what you can see, we have a control circuitry. We have a control circuitry, and which gives the signal of subtraction as well as signal of shifting. You also know that as soon as the machine starts, we give a start signal here, and when we give a start signal, the first thing what happens is it loads the machine. And loads the machine means what? In this big register, which you can see is a 9-bit register, actually speaking, your data is loaded in this x0 to x7, x0 to x7, because we will be dividing a 8-bit data by 4-bit. Other thing you should understand is, we generally do the operation with 4, 8, 16 bits only. 4-bit is a nibble, 8-bit is a byte. So we do the operation of, in this we are doing the operation of 8-bit division by 4-bit. So our loading will happen x7 to x0 only. So this is our 8-bit dividend loaded here, and our divisor is loaded here in y3, y2, y1, y0. So divisor is here, dividend is here. Next, what happens? After the start signal and after the loading operation, then we start with the shift only first, because we know that you should have a place to keep your quotient also. So what happens here is, I will tell you in total. As soon as the machine starts, it shifts. Now you can imagine that when it is shifting, the data is filled from x8 to x1, and x0 is vacant now. X0 is vacant for what purpose? X0 is vacant to store your first bit of quotient. So what happens? I'm starting from the beginning. When the control unit starts, the start signal will become high, ST will become high, and after that, this LD, the load will load the dividend and divisor, and then it will start the operation. And this, after it is shifted here, so you can imagine what will happen. It will have 1 double 0 and double 0, and this 1 double 0 double 0, which is stored in x8 to x4, is compared with this, is compared with y3 y2 y1 y0, and when it compares, it sees that this is higher, the dividend register bits are higher. So when this is higher, C becomes 1. And when this C, comparator C becomes 1, it gives the input to this control saying that dividend is higher than the divisor. And when this C becomes high, the control will tell that subtraction has to happen. So SU goes here and it will indicate that now subtraction should happen. So the subtraction happens, and the subtraction and comparator is kept in this combinational logic block. So subtraction happens, and what will happen? Where will be the result of subtraction? You can see the result of subtraction is this one, 0 triple 1. So when you subtract 1101 from 10000, you get 0 triple 1, and this 0 triple 1 is stored here. Where it will be stored? It will be stored at x7, x6, x5, x4. So your result will come here. So this is subtraction operation done. After subtraction operation, next is the shift operation. So what happens then? Your this 0 triple 1 and the remaining bits of the subtraction operation is 0 double 1 only. I hope you remember. The subtraction operation is 0 double 1 only. It shifts to the left, and this 1 which was at this side, this 1 also comes in this x4 bit. Now what will be left in x3, x2, x1? It will be only your LSBs here. So what happens whenever comparator is high? It gives an indication that subtraction should happen. After subtraction, shifting happens. So instead of moving right here, we move the dividend left in this thing. So now next what happens? Again comparison happens, and comparison says that my divisor is smaller than the current bits in the register. So when comparison becomes smaller, then C becomes equal to 0. C equal to 0 means what? No subtraction will happen. Only shifting will happen. So the shifting happens and it shifts further to left. That means I am ready, and when we shift it to the left, now this zeros are exhausted here. Zeros are exhausted here. And you get your double 1 double 1 in x7, x6, x5, x4. Now comparison happens with this, and when the comparison happens, it sees that the resultant of this subtraction is higher than your divisor. Always y3, y2, y1 will have this 1101 stored in this from the beginning to the end of the operation. Now C is equal to 1. C equal to 1 means what? Subtraction will happen, and after subtraction, shifting will happen. Next you get this 0, 1, 0, 1, where? Here. And again when comparison sees that it is your divisor is higher, then again C becomes 0 and your subtraction becomes 0, means subtraction will not happen, only shifting happens. Now what you can see, at the end of this operation, whenever subtraction was high, it was stored 1 here, and when you shift, your divisor bits are also shifted. When comparator was 0, subtraction used to be 0, and we were storing 0 only here. So first time 1 came here at x0, then shifting happened, x0 went to x1. In next cycle, subtraction did not happen, so we got a 0 here. Then shifting happened, so x2 became 1, x1 became 0, and this was vacant. and next operation subtraction happened. So this 1 came here. Now this is 101. After it became 101, again shifting happened. So your 101 of x3, x2, x2, x1, x0 went to x3, x2, x1. Again your x0 was vacant. Last this 0 was stored here. So what happens after the complete operation? X3, X2, X1, X0 will be stored with the quotient. I hope you are understanding. X3, X2, X1, X0 will be stored with the quotient. And what will be there in this? X8 to X4, it will have the remainder. So remainder is 0101. Your X7, X6, X5, X4 will be having 0101. Now you can understand why I kept this X8 bit here. X8 bit was taking care of any overflow. If your, by chance, if your subtraction results in a negative result, I hope you remember that whenever a minus result comes in binary, the MSB is 1. The MSB is 1, and that indicates the overflow in the sense that I am getting a negative answer. Just to keep my circuit complete, that is kept. And this overflow indicator also indicates that only, that you are not keeping the appropriate number of bits or you have a negative answer. So this is your block diagram of binary divider, which is taking care of shift operation. Of course, start and load is there in the beginning, which is taking care of shift operation, subtraction operation, and meanwhile it is storing your quotient also and your remainder also. So this is a very simple block diagram. Now let us see this is all showing. See, this is showing how your quotient is being stored. Quotient is being stored and being shifted. So this is how your quotient, third quotient bit. Finally, in the dividend register, you get quotient as the first 4 bit and remainder in the leftmost bits. So this is the explanation. Of course, you can also go through it later. This is trying to tell if you have more than required number of bit, overflow occurs. If your quotient is greater than that much value, so it overflow will occur. Okay, now control circuit design is done. Of course, you need not go into the detail of that, but of course you need to see the state graph. State graph, as you have already understood your block diagram of divider, you should see this. This is your initial state. Till the start is 1, it will remain in this state only. That means if start signal is 0, it will remain in S0 state only. Once start become 1, loading happens. That is the first thing. Loading happens and it will go to S1 state once loading is done. If at this state only, it will see that if the dividend bit is higher than what is available in your machine, it will go back to say the overflow is happening. V is for overflow. It will go back and the division operation will not happen only. But if your comparison shows, that is C dash means if comparison shows that the dividend is higher, the dividend is lower than the divisor, it will only shift. C dash, only shifting happens. I hope you remember that I told in the beginning of the operation, before anything, shifting happens. So the shifting happens here. Then the comparison starts. If C is 1, subtraction happens, and also the same thing is stored as the quotient bit. So this subtraction is happening if C is 1. And if C is 0, only shifting happens. So what you can see, if C is 1, subtraction happens here, and after that shifting happens. If C is 0, it will not go to this state. It will directly shift only. I hope you are understanding. There are two possibilities. One is subtract and shift. Other one is only shift. So S2 to S3 only shift. S2 to S2 once, and then S2 to S3 means subtract and shift. Same operation repeats another 3 times, that is subtract and shift or only shift, subtract and shift or only shift. Last operation, when it is doing for the 4th time, it will tell that along with the 4th time, it will go back to the initial state. So that means if subtraction is happening, your last bit 1 is here and quotient bit also it will be stored, otherwise it will be only shifted. So this is the state graph of divider control circuit. If you have any doubt, you should ask me. Okay, now I will go back to this one. Of course, you know how your subtractor looks like. This is your parallel binary subtractor. You all remember what the subtractor do. Okay, now let us understand this circuit. This is a block diagram of divider using bus notation. Now, observe it carefully. It's not difficult. Observe it carefully. What we are showing here is this is your dividend. This is your dividend register. Okay, it is showing the internal block diagram. Okay, this is your dividend register. Okay, and this is taking care of loading, subtracting, and shifting. Loading, subtracting, and shifting. Of course, this subtraction and shifting operation comes from where? It comes from your control unit. Here they are not showing you the control unit. They are showing the internal diagram of the left hand side, the register and all. It is not showing you the control unit. So what is happening? It is showing your the dividend register here. Okay, and this is also taking this complete part. This what is there in your dotted line, this is taking care of your dividend register. So what we can see here is your divisor. See here, you have your divisor here, that is 4-bit. 3:0 means it is a 4-bit number, and the 4 bits are going here, and this is your x8. You remember x8 was there, which was your 9th bit. X8, which is put as 0 here. So this will come here as a 5-bit subtractor, and it is going here, and this is taking care of loading it with the dividend register, that is your 8-bit. So you can see that this one is your 8-bit, this one is your 8-bit, right? And this is taking care of the time when the subtraction is required, not now. Okay, time when the subtraction is required. So this is a multiplexer which will take care of shifting and subtraction also. So this will take care of shifting as well as subtraction. So dividend will be loaded first. When your mux will be made high, this will be loaded first. Later, when the subtraction happens, that time this part will come into picture. So dividend part loading is here, subtraction part is coming from this side, and they are also trying to show the bus diagram. Bus diagram means bus is a combination of wire which will have 8 wires to carry 8 bits. That is why this arrow with this 8 means it is a wire to carry 8 bit, and the 9th bit is 0, and together this is called a bus merger. 8-bit here and 9th bit here together is merged to get your 9 bits here. And here what you can see, this 9-bit is coming here, and it is splitter. Splitter means what? We want only X MSB 4-bit from where we were subtracting the divisor. I hope you are remembering what I'm saying. See here, you are subtracting this part only. So what do you require? You require this part only. So in subtractor, what you put in subtractor, you put only this part of the dividend, and the divisor is subtracted. Okay, so what we are trying to show here is that only. So here you will see what is happening. Same 9 bits are coming here. You will check here properly. same 9 bits are coming here, but what we are taking out of that 9 bit, we are taking only the initial one, those 4 bits only. So x 3 is to 1 is 3 to 1 and x naught. So 4 bits are being taken here, and this is the, this is subtracting what, x8 is to x4. So this okay, what, okay, I will explain here only. X8 is to 4 means your msb's are being subtracted with the divisor. Can you see here? Only the divisor part is here. So divisor is being subtracted by the msb of your dividend. So msb of the dividend and the divisor are put into this 5-bit subtractor. The result will come here, and that result will be loaded to this part, so that your result, when you make your mux select line as 0, that only will go here. I hope it is clear. This part is taking care of subtraction, and this was initial loading only. So initial loading of this, and then this came here. The MSBs were subtracted, LSBs were copied as it is, and then it was being loaded. So this is taking care of the block diagram of divider using bus notation, how things are being done inside the circuit. The similar thing you will see here. It is alternative divider. Again, load and subtract is coming here. Here they are trying to show again 2 is to 1 mux, where the bit size is 8 bit. So it is also showing the same thing in a simpler form. You have your subtractor. It is subtracting what? This 7 is to 4 shows you MSBs of the divider. So MSBs of the divider will go, and divisor will go. MSBs of dividend will go, and divisor will go, and subtraction will happen. And this will give you the quotient also if the subtraction is happening. So this is one an alternative divider. This is also one of the possibility. All these are similar to each other. There is no much difference among this. If you read it carefully, you will understand. Further any doubt, you should ask me.